So, picture this. You're a software developer and you are on a mission. You want to find and fix every single hidden vulnerability in your code before the bad guys do. And you've got this super powerful tool on your side, an automated system that just relentlessly hammers your software with random junk to see where it breaks. This whole thing is called fuzzing. And honestly, it sounds like a silver bullet for security, right? But what if that silver bullet, that powerful ally that's supposed to make your life easier and your software safer, ends up being your single biggest headache? What happens when the solution actually becomes part of the problem? All right, let's dive right into this. We're going to step into the shoes of a developer who's just trying to use one of these fuzzing tools. Their goal is super simple: find the bugs, make the code secure. But as you're about to see, the journey is, well, it's anything but simple. Okay, so a quick refresh on what we're even talking about. Fuzz testing, or just fuzzing, is basically like throwing a million curveballs at a piece of software to see if you can make it crash. You're just feeding it tons of invalid, unexpected, totally random data. The whole idea is to find those weak spots before an attacker does. It's a really, really crucial part of modern software security. So our developer, they try to get started. And bam, they hit a wall immediately. The fuzzer just won't install right. Maybe it's not compatible with their compiler, or the configuration files are an absolute nightmare. They end up burning hours, maybe even days, just trying to get the darn thing to run. But okay, let's say they finally get it working. They kick off a test and their entire computer just grinds to a halt. The fuzzer is eating up every last bit of CPU and memory, making it completely impossible to do any other work. It's a total resource hog, and this powerful security process has now become a massive bottleneck. And then, after all that waiting, the fuzzer actually finds a crash. Success, right? Well, not quite. The report it spits out is totally confusing. The logs are a complete mess. And when they try to recreate the bugs so they can, actually fix it, they can't. It's gone. A one-time fluke, a ghost in the machine that's pretty much impossible to debug. Now, here's the thing. This story, it isn't just about one unlucky developer. For years, these kinds of frustrations have been whispered about on forums and in team chats. It's this shared universal pain in the software world. But for the longest time, it was all just anecdotal. Until now. Some researchers from a few universities decided to do something different. They decided to stop focusing only on making fuzzers faster or smarter, and instead to focus on the human experience. They set out to conduct the first big study to systematically map out every single one of these real-world frustrations. So, how'd they pull it off? They had this really clever two-pronged attack. First, they went public. They dove into 8 to 9 GitHub issues where developers were just openly talking about their problems with fuzzing. Then, they went private and surveyed 106 professional fuzzing practitioners to get their direct, unfiltered opinions. And this was not just some casual reading. No way. They actually built a dedicated web app to systematically go through, label, and categorize every single challenge mentioned in those GitHub threads. This is how they turned all that messy, unstructured conversation into clean, hard data. So after all that digging and sorting and analyzing, they built a complete map of all the human-centric challenges in fuzzing. And how many distinct problems did they find? A staggering 39. This wasn't just one or two little issues, it was a huge, complex web of headaches. Okay, so out of those 39 challenges, which ones are the real heavy hitters? Which ones cause the most pain? Let's get to the results and see what the data revealed about developers' biggest headaches. So, looking at those public GitHub discussions, the data told a very familiar story. The number one complaint, by a long shot, was that initial nightmare of just getting the fuzzer set up and running. Right behind that was environment issues, the fuzzer breaking after an update, and, you guessed it, the classic problem of finding a bug you just can't reproduce. And honestly, this quote from one of the survey respondents just says it all. He said, "Fuzzing involves getting build systems to work. Build systems are the devil."
I mean, that perfectly captures the raw frustration of that whole setup phase, doesn't it?
But here's where things get really interesting. When the researchers looked at the private survey data, the number one problem was completely different. It wasn't about setup. It was this much more subtle technical issue, having a really hard time getting the fuzzer to generate the right kind of weird inputs to test specific, hard-to-reach corners of their code. It's the kind of deep, simmering frustration you might not post about publicly, but it's a constant battle for developers. The study also uncovered another fascinating insight. It turns out the challenges you face with fuzzing actually evolve as you get more experience. The struggle changes, for sure, but it never really goes away. For beginners, the biggest hurdles are exactly what you'd think: getting the fuzzer set up and dealing with terrible documentation. They're just trying to get in the door. But for the experts, the problems get way more complex. They're wrestling with advanced issues like figuring out how to define good fuzzing targets to get meaningful results and how to scale the whole operation to run on massive code bases. So here's the crucial point. We've now mapped the pain. We have the data. So the next logical question is, what do we do about it? How do we use this information to forge a better fuzzer? One that actually helps developers instead of fighting them? Well, the research points toward a few key ideas. Imagine fuzzers that just seamlessly plug into a developer's existing tools, instead of making them start from scratch. Or what about smarter tools, maybe with a little AI help, that could act like a guide and recommend what to test? And maybe most important of all, we just need way better documentation and onboarding to lower that super steep learning curve. So these powerful tools are for everyone, not just a handful of security gurus. And this really brings us to the final critical question. Because all these frustrations we've been talking about, they're not just minor inconveniences. They are major roadblocks that stop a critical security tool from being used as widely as it should be. So if we can solve this human side of the equation, if we can build tools that empower developers instead of frustrating them, can we in turn build a fundamentally safer and more secure digital world for all of us?